Hello, welcome to Math with Beth, and we're going to look at some integration techniques, specifically U-substitution, and see when you would need to use that. So U-substitution is when you're trying to take an antiderivative of something that is more complicated than stuff that you could do just the basic power rules with, or basic ln rule, or e to the x. So basically, if it looks like a function within a function, the same reason we would use the chain rule back when we were doing derivatives, or examples where it looks like we would do the product rule or the quotient rule if we were doing a derivative. That's usually when we're going to use U-substitution. So this first example looks like it's a function inside of a function. So I'm going to try to use U-substitution, which means I'm going to take the inside function and call it U, and then see what the du would be. So what would be the derivative of this would be 3 dx, and see if I can now use those two pieces of information to rewrite this problem. So I'm going to keep the integral sign because I haven't done the integral, but I'm just trying to rewrite it. So this is now my u. So couldn't I rewrite this as u to the 7th? And then since dx is part of this, I could say du here, but I'd have an extra 3. So since du has an extra 3, I have to balance that out by doing the opposite out here. So that's the tricky part. If something is extra, something shows up here that you don't have, you have to balance that out by doing the opposite out front. So now that you've done that, we're just going to do the antiderivative here. So normal power rule now, add 1 and divide by that. And that is our answer. But now we can put what u actually was back in. So 1/3 times 1/8 is basically 1/24. Our u was 3x minus 4, and that was to the 8th, plus c. So let's try another one. So this next one's not quite the chain rule type, but a product rule where you have two separate functions being multiplied. So I'm going to try to take the more complicated one and the one that might lead me to the other one. So in other words, I'm not going to use e to the x to the second power because then my derivative would also be an e and I don't have another e. I'm not going to use 2x as my u because the derivative of that would just be 2. So where's all this going to come from? So here is what I'm going to use as my u. And the more you do this, you'll get used to what to pick for your u. Because if I pick this, my du would be 2 dx. So the only thing I don't have is the e. So we'll just keep the e, but call it e to the u. And then, oh, I did this wrong. Really, it should have been 2x dx, which is perfect because that's exactly what I have here. So this time I don't have anything extra. So I don't need to put anything out front. I just need to call all of that du. So how do you do the antiderivative of e to the u? It's just e to the u plus c. So now we can plug back in what u is. So e to the x squared plus c. Let's do another. This one is kind of like having a chain rule and a product rule. So when in doubt, use the more complicated version or the thing with the higher power. So if I had to choose between 3x squared or x to the third plus 1, I'm choosing x to the third plus 1 in hopes that I'll then end up with the other answer. So I'm going to call that my u. If you start with one thing and you end up, whoa, I'm going in the wrong direction, just start again and pick a different u. So at first, when you're not good at this, if you accidentally picked this, you'd see that the du wouldn't be heading you in the right direction. So if I pick x to the third plus 1 as my u, my du would be 3x squared dx, and that's perfect. So the only thing I don't have is this 10th power. So I'm just going to rewrite this u to the 10th power du, because that takes care of this is my u, and all of that is my du. So all I have to do is integrate that. So power rule, add 1 and divide by that same thing. And now put the u back in. So really, it's just a way to make the problem less complicated so that you can do the integration and then you plug it back in. All right, finally, one that's a quotient, sorry. So again, when in doubt, choose the one with the higher power. So I'm going to choose 1 plus x squared as my u and see if that works out nicely. My du would be 2x dx. Perfect. So I can rewrite this as 1 over u du. Remember, the integral of 1 over x dx is ln, right? So the integral of this would just be ln, absolute value if necessary, of u plus c. Bring the u back in, plus c. And that is how you do integrals with U-substitution. So definitely practice more of these. If you find yourself picking the wrong thing over and over again, feel free to let me know if you want me to do some more examples. Hopefully that helps. Give it a try.